Hi there, welcome to the toolkit pages. I have these toolkit pages that I give my students to fill out so that they have a simple, concise resource about how to do things, and they keep them in a duotone. This is the toolkit page for one-step algebra questions. And when we're doing algebra, what's most important about algebra is the process. It's easy to look at this question, x plus 5 equals 12, and say, okay, well, x is 7, it has to be. But what matters is the process, because next time you look at this, it's going to have some really ugly decimals or fractions, and you're not going to know what the answer is just by looking at it. So that's why your math teacher talks about the process and why your math teacher nags you to show your work. It's because we love you, okay, and we care about you, and we want you to be successful going forward. Okay, so the way I teach algebra is the variable is, of course, the letter. So in this case, the variable is the x that's there. And variables are these antisocial creatures, and they just want everybody to go away and leave them alone. Okay, that's the story that I tell. So when we're looking at this question, what's bothering the variable? Well, in this case, what's bothering the variable is the 5. So our next question is, well, how is it connected and how do I get rid of it? What do I need to do so that there is just an x on the left side of this equation? Well, I have an x. Somebody came along and added a 5 to it. And if I want to have just an x, I need to subtract the 5 from it. Okay. Now, in this video, I'm going to show you how to show your work because it matters, okay? And the way we show this is we write below it, just below, we write minus 5 because that's what we're doing on the left side. And whatever you do to one side, you have to do to the other side. So I'm going to write minus 5 on the right side as well. Now, what this really means is I have x plus 5 minus 5 equals 12 minus 5. But mathematicians are lazy, so we're not going to write all that out if we can just write what's on the screen here. So I've written this. I'm going to say, well, I've got plus 5 and minus 5. That's 0. So all I'm left with on the left side is my x. And on the right side, 12 minus 5 is 7. Ta-da! Now, you'll notice I use two colors. I do that very intentionally. One color shows what you're doing. That's purple in this case. And the other color shows what you get, which in this case is the x equals 7, and that's that turquoise or blue color. Okay? The other thing I want to draw your attention to is that I left some space in here. Okay? I tell my students, especially my grade 9s, that this year is all about getting you good math habits, and I'm going to nag you mercilessly about them. Leaving that space is really, really helpful. It's less important if you're using two colors, but I know you're not going to keep using two colors. Leaving the space is going to make things so much more clear when everything is done in pencil. Okay? All right, let's look at the second question. Y minus 4 equals 6. What's bothering the variable? Well, that 4. What do I need to do there to get rid of that 4? Because it's minus 4, right? So I need to do the opposite, which is I'm going to add 4. So I'm going to write a plus 4 here and a plus 4 here. All right? And then I cross out my minus 4 plus 4. And the reason I do that is because when I'm looking back at this, now remember, these are the simplest algebra questions, and you are eventually going to do some very, very complicated algebra questions, and you are going to make mistakes, and you are going to have to go back through it and see what you did so you can find your mistake. Promise you that is going to happen. So if you cross out the minus 4 plus 4, that tells you, when you come back to it, why you added 4 to both sides. Oh, well, I crossed it out there. That must be why I did it. Okay? The other thing I want to point out is that what you do is always driven by the side with the variable. Okay? It's not what's on the left side. So you don't always do what's on the left side. You do what the variable is telling you need to do. You want the variable to be by itself. Okay, all right, so we have y minus 4 plus 4. That's y plus 0. So, I'm change colors here. So we just have a y here. And on the right side, we have 10. All right. Okay, and then we're going to go to multiplication and division questions. So just remind you that I'm looking at the 2b equals 14. A number beside a letter or two letters beside each other, that means multiply. Okay, so this actually means 2 times b equals 14. What's bothering the variable? What's bothering the b? The 2, right? How do I get rid of it? Well, it's multiplied together, so I need to unmultiply, which is dividing. So I'm going to divide the left side by 2, and I'm going to divide the right side by 2. And it's important you write it this way, because as you go on in math, you're going to do a lot of canceling of what's in the numerator and the denominator of a fraction. I'm not going to get into that right now, but showing it this way is just much simpler. If you show it as, let's say you had 2b equals 14 and you write divide by 2, you know what? A lot of the times you're going to think that says minus. I know this because I see this happen all the time, okay? So we actually in math have a lot of error correcting techniques where we show things in certain ways so that we know what it means. And that's what's going on here. So I'm going to write it with the fraction line, which does mean divide, right? And then my 2's cancel out. So I had a b, somebody multiplied it by 2, and then I divided it by 2 again, so I'm left with just b. So on the left side, I have b, and on the right side, I have 14 divided by 2, which is 7. Okay? And then this one here where we have m divided by 3 equals 15. Now this one drives me crazy because students never want to show their work correctly on this. So I'm going to show you the wrong way to do it first. So it's m over 3 equals 15. And so somebody took your m and divided it by 3, so you need to multiply by 3. And students always seem to want to go times 3 and then cancel those out. Please, 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 please don't do that, because what you're doing when you do that is you're imprinting in your brain that it's okay to cancel two things that are both in the denominator. And it's not. It's never okay to do that. So instead, you just put your 3 up here. That wasn't any harder, was it? But it's a much better habit because now you're canceling something in the top with something in the bottom. You're allowed to do that, okay? Similarly, on the other side, students want to go times 3 up here. Well, does that remind you of anything? Because I think that looks like an exponent. And one of my sayings is be smart about your lazy. Make things as easy for you as you can, which means never write something that looks like an exponent unless it's actually an exponent. So don't write it like that. You're going to go times 3. Same size, same line, makes it really clear that that's a multiplication. Or use brackets, or I wouldn't use the X for multiplication here, but brackets are fine. I often use brackets. So on my left side, I'm left with m. And on the right side, I have 15 times 3, which is 45. Okay? You'll notice that I didn't write 15 times 3 equals 45 anywhere on that page. And that's important because when you're doing algebra, the first line equals the second line equals the third line equals the fourth line. When we get to some more complicated questions, I'll show you how to do those calculations off to the side, but you shouldn't need to do any of that with this level of question. Okay? Okay. Next one is this w minus 7 equals 21. Or sorry, 7 minus w equals 21. So this one, if you look at this and you go, okay, so what's bothering the variable is the 7. How's it connected by subtraction? So I'm going to subtract 7 on each side. Or I'm going to add 7 on both sides. Now that's not going to work because this question actually has a negative w in it. It's got a minus w. So there are a couple of ways that you can do this, but we want to know what positive w is. So probably the best way to do this is to say what I've got over on this side is a positive. Oops, I want to change the color on that. Oops. I've got a positive 7 here. So I need to get rid of that, which means I'm going to subtract 7. Okay, so I'm going to subtract 7. on this side, and I'm going to subtract 7 on this side. These cancel out. What am I left with? I need to be careful here. I'm left with negative w, which equals 21 minus 7, which is 14. Sorry. So that's negative 7, or negative w equals 14. But I don't care what negative w is. I want to know what w is. So that means that I need to do something to my left side to have just w. So you can multiply or divide by negative 1. So if I divide that side by negative 1 and I divide that side by negative 1, and you'll notice I changed colors here, then a negative divided by a negative is a positive, and anything divided by a 1 is just what you started with. So I've got w on the left side, and 14 minus or divided by negative 1 is negative 14. Okay? Now, eventually you don't need to show that. You just change the signs and it's all good. But it's really good to know why you do that, because when the questions get more complicated, it's not always as simple as just, you can't just change the first sign. Okay? Okay, I'm going to, let's continue on and do the checking your answers. It's really important that you check your answers. This is the formal way of checking answers, and I'm going to do it wrong first. So this one is going to checking a wrong answer, and this is checking the right answer. Okay. It's really important that you check it and that you have a formal way of doing it, but you should be checking every question, every calculation you should check. Just pull out your calculator and plug it in. You don't need to write it out every time, but you should know, you should understand what you're doing when you're checking the questions. Okay? All right, so when I teach this, I say, well, what's the left side of the equation? So the left side is anything that's to the left of the equal sign, which is in this case r minus 7. And the right side is whatever's to the right of the equal sign, which in this case is 9. And in the middle here, I put what I think r equals. So I think that r equals 2. Okay? So if r equals 2, then I'm going to go to the left side and I'm going to replace my r with 2. So this becomes, instead of r minus 7, now becomes 2 minus 7. And 2 minus 7 is negative 5. And negative 5 is as simple a number as I can get. I can't reduce it. I can't do anything else to it. I'm going to circle it because I'm finished with the left side. And then I go up to the right side and I go, oh, well, I've just got a 9 there. I can't do anything with that either. I'm just going to circle it. And now I'm going to compare them. Are they the same? No, they're not. That means somewhere there's a mistake. Either my r does not equal 2, or I made a mistake on the left side there where I did some calculations. My advice is actually to check your calculations in this checking bit first, because that's usually pretty easy to do. But it means there's a mistake somewhere for sure. Okay. All right. And now let's do it when we have the right answer. So this time I'm going to say r equals 16. So my left side is r minus 7, which is 16 minus 7, which is 9. So I'm going to circle that. And on the right side, I have 9, and I'll circle that because I can't make that any simpler. Draw the line to say, yes, I'm now comparing these. Oh, they're the same. That's right. Okay? And then make sure that you do something, box your answer, or circle it or something, so that you are really clear about what your answer is. Okay? All right. Thanks for listening. Bye.